So we're going to use transformations to prove that vertical angles are congruent. And if you recall, vertical angles are two non-adjacent angles that are formed by intersecting lines. So they have a common vertex, and in this case we're going to be proving that angle CBA is congruent to angle DBE. And to do that, because we're using transformations, I'm going to use my patty paper, and I'm going to put that on top of it. And I'm going to sketch in angle CBA. Being very careful to keep the patty paper holding steady. And I've got A here and C here. And then I'm going to hold it at point B. And I'm going to rotate this 180 degrees. So, first rotation, once again this line is straight, and let me move it over so it's right. So this is 90 degree rotation, and this is 180 degree rotation. And there we have that angle CBA maps directly onto angle DBE. So in this case, we could also call this angle A prime, B, C prime. So this would be A prime, which would equal D, and C prime, which would equal E. And we just showed that angle CBA is congruent to angle DBE through rotating 180 degrees. Now, because I've just proved the two angles are congruent through a transformation of rotation of 180 degrees, then I can say that if angle CAB is equal to, let's say 33 degrees, then angle DBE must also equal 33 degrees. Then I can also look at this and say, well, angle angle ABD is a straight angle. It's a straight line, so its sum is 180 degrees. So angle CBD must be 180 minus 33. And because angle CBD is vertical to angle ABE, angle ABE must also be 180 minus 33 degrees, which would be 147. So both these angles are 147 degrees. So 147 plus 33 gives us back our 180 on both sides. Now we can extend this congruency, finding objects congruent or angles congruent, through transformations further by using a transformation to prove about parallel lines cut by a transversal. Okay, so we don't want to forget that isometric transformations are transformations that preserve the distance or angles between the pre-image and the image. So what I have right here is we're going to show how through translations, okay, which is an isometric transformation, we can show that when two parallel lines are cut by a transversal, that some angles are congruent, some angles are supplementary. Okay, so once again, what I'm going to do is I'm going to copy this on to the patty paper. And all I'm going to do is I'm going to move it down along this line right here, okay? So it's moving along this, we could say it's moving along this vector approximately this far, okay? So as I move it along that vector, now what I have is I have two lines. They have to be parallel because it's just a translation, and we know that lines are parallel between the pre-image and the image when we're doing a translation, okay? So if these two lines are parallel, then that means that the angles are also congruent. Okay, so that means that this angle here is congruent to this angle here. Okay, so I just folded the patty paper over and drew the angle, or excuse me, drew the line along the edge of the ruler with the patty paper. So now I have that same line. And as I was saying, we know that this angle has to be congruent to this angle by definition of an isometric transformation, okay, because it has preserved the angle measure. Okay, so if this angle is congruent to this angle, then I'm going to extend this line a little bit to make it appear as a true transversal. Then we know that this angle here has got to be congruent to this angle here, because this here makes a straight angle and this makes a straight angle. So both of these are sum up to 180 degrees. Okay? Just like before up here with the vertical angles. And we know that this one plus this one must also make 180 degrees. And what's interesting here is now we have two vertical angles, okay? And from up here we know that vertical angles are congruent. And here we have two other vertical angles. So they must be congruent, okay? And we know that if this angle here is congruent to this one here, then this angle here must be congruent to this one here, because again, this is a straight angle, and together they must sum up to be 180 degrees. And this is vertical to this one, so they must be congruent. And then this one is vertical to this one, so they must be congruent. So using transformation of translation, we've proven that different angles, when you have a parallel line or two parallel lines cut by a transversal, we've proven that angles are congruent and or supplementary. And if you recall, if we were to label these angles and say this was angle 1, 2, 3, 4, 5, 6, 7, and 8, we'd say that angles 2 and 6, 3 and 7, 1 and 5, and 4 and 8 are all what we call corresponding angles. And that's one of the theorems in geometry that say when two parallel lines are cut by transversal, corresponding angles are congruent. And we've proven that that's true through our use of translations. Now they also have a theorem that says that alternate interior angles are congruent, and that would be angle 3 and angle 5, as well as angle 4 and angle 6. And those are alternate interior angles, and those must also be congruent to each other. So the pairs are congruent. Okay? Just like here, the pairs are congruent. Okay? So, and as we continue down through this, we can see that all the theorems that we learned from two parallel lines cut by transversal, that where they said that they were either supplementary or they were congruent, we can prove that using the property of translation.